Howdy folks, and welcome to part 5 of my comprehensive guide to pfSense 2.3. Part 5 is going to be a little bit different in format in that it's going to be split up into multiple subparts. And the primary reason for that is just because it's more indexable. You can go back and find a subpart easier. And I kind of want to separate this out so that it doesn't turn into a massive 1-hour video like my previous part 4. So in part 5, I'm going to go over the web user interface. So I'm going to go for a little bit of a tour, sort of show where certain things are. I'm going to stop and talk about a couple things that I'd like to point out now rather than later. And the separate subparts are going to be on things I want to talk a little bit more about right now. But they sort of don't deserve their own part on their own. But they have enough content that I can separate them into their own video. So I'm making this up as I go. So hopefully everything makes sense and is sort of continuous. So as you can see, I have the web user interface, and this is exactly the same machine as you saw that I installed in part 3. Nothing has changed. And the first thing that I'm going to do is I am going to update it. As you can see, version 2.3 blah 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 is available. And we can update it by clicking on the little cloud here. There's also a system update. It basically takes you to the same place. And so I want to do a system update. I'm just going to confirm the update, and actually there's a pretty serious difference in here. So I'm just going to confirm that, and pfSense is going to fetch all of the required files for the update, and it's then going to apply them. And depending on the severity of the update, pfSense may or may not require a reboot. So in this case, you can see that a reboot obviously was required. It automatically reboots. So it doesn't give you the option to reboot later. It will reboot immediately. So you should always make sure that you only do this when you actually want the system to go down. So you can see in that VM, it's shutting down, and it will reboot. Okay, so pfSense is done updating. Did most of the update after it rebooted, actually. So everything is looking good there. We've been automatically logged out, of course. And of course, that cookie issue still exists because I haven't cleared the cookies on this VM. But anyway, so the latest version has been installed, and I'm going to proceed with this video. So updating pfSense is pretty painless in my opinion. When you go from a minor version to another minor version, generally you don't have that much to worry about. When a major version comes out, like for example those that are going to eventually end up migrating from 2.2.6 to 2.3, that is going to be a much more serious update, and there's the potential for a lot of breakage. There are release notes that are provided on pfSense's website as to what has changed and possible issues in the upgrade path, so that you should be aware of those, of course, before you update. But I'm going to get into updates probably in a later video when I talk about maintaining an installation. So now that we've updated to the latest version, I would like to go through with a web user interface, point out a few things, where certain things are. I'll explain things. I'm not going to explain every possible option for the sort of general stuff, just because I think that's very tedious, and there is help on the pages that will sort of give you an idea as to what things do. I'm just going to point out some things that I generally like to change, and there's going to be separate subsections of this part 5 that go into more detail on certain things. So I'll start with general setups, considering that sort of makes sense to start here. Most of the stuff on this page is actually changeable in the wizard that you would have gone through after installation. Now, as of recording this video, February 20th, the latest version, the latest build of pfSense 2.3 has a bug in this particular page, such that you cannot save any of the settings on this page due to an input bug with the DNS server addresses. Now, I've actually filed an official bug with the pfSense bug tracker, so hopefully this will get fixed. It should get fixed before the stable 2.3 comes out. So once it's ready, this should be a non-issue, but unfortunately, this is what happens when you use beta software. There are going to be issues. I mean, I mentioned this before. The web user interface is brand new. It's going to have small bugs like this. So no matter what you change on this page, if you try to save it, if you have two DNS server addresses which are blank, it basically does a comparison on them that says, oh, they're both blank, so they must be identical, and therefore, you can't do that. So yes, if you fill in 4 DNS server addresses, then this page works fine. But I'm reserving this for my DNS video, so I don't want to make the changes now, because if I make changes now, I won't be able to undo those changes, of course, due to the same bug. So unfortunately, I can't make changes on this page. I don't need to make changes on this page right now. But if you do, unfortunately, you're going to have to wait until the DNS video before you can do it. Because if you enter in DNS server addresses here, it's going to skew with the tests that I want to run in the DNS video. So I guess this is just, it's unfortunate that this is the way it is. But here you'd set the host name of the domain. I do want to make a correction for what I mentioned in the install video. Local domain is actually not bad. It's local, which is the bad domain that messes with MDNS. So I apologize for getting that wrong. This is quite nice about the new user interface, is that it has sort of these little bits of help on the page. I mean, it's not enough to teach you about something, but it's enough to jog your memory and sort of give you a little bit of context as to what a setting does or is. So I apologize for that mistake. So again, DNS I'll go over later. Localization's pretty self-explanatory. And web configurator settings, this is just sort of the WebUI settings. So themes, currently there's only 2 themes. There's a dark theme and a light theme. The older versions of pfSense had a lot of other themes, but of course they all need to be rewritten now that the WebUI has changed. So eventually there will be more themes. The top navigation is just this bar here, whether it scrolls with the page like by default, or if it stays fixed at the top of the page like this, where it's always accessible. Now, of course, because of this error, the setting didn't actually get saved, because of course it just goes back to the way it was before. But generally, I actually like to keep it fixed so I don't have to bother with scrolling up. I know that there's these buttons that take you to the top of the page, but I couldn't be bothered with that. Dashboard columns is simply the number of columns you have on the dashboard. So there's 2 by default. I'm not quite sure how well it's going to work with more columns than that because it's a new feature, but I mean, that's why it says beta on it. But for widescreen monitors, I think it would be a nice thing, and eventually that will be stable. And just some other general stuff that I'm not really going to bother to go into. So I'm just going to sort of start from the beginning now and start with the advanced tab. So in the install video, I showed how you can change the protocol of the WebUI from HTTPS to HTTP to get rid of that self-signed certificate issue. Of course, if you have your own certificate that isn't self-signed, you can, of course, add it and use HTTPS on any machine, or you can add the self-signed certificate to your local computers. You can use HTTPS if you want, but I generally don't even bother with it, so I just leave it on HTTP, and I'll go over certificates and stuff in a future video. You can change the port that's used for the WebUI. So port 80 is HTTP and 443 is HTTPS. So you can make this a non-standard port. So that way you'd have to actually add the port number when you want to access it. So you have to put colon in the port number. This could be useful for maybe a bit of extra security by sort of hiding or obfuscating how to get to the UI. In reality, it's really there so that you can get around issues if you're running a web server, for example, on your pfSense box, which is quite odd. I don't think you should do that, but yeah, it's just there. The setting exists. If you leave it blank, it just defaults to the default ports for each of the 2 protocols. Max processes, most people will never need to change this. It's basically how many independent things the WebUI can do simultaneously. So if you're like me and you open up a whole bunch of tabs for different parts of the WebUI, you'll still be fine with just 2 processes, because each tab isn't going to be doing a request at exactly the same time. But if you have, let's say, you're in a small business and you have an IT team and they all have access to it at once and they're all making config changes, and 3 of them happen to submit a request at exactly the same time, well, there's not going to be enough processes for that. So generally speaking, you only really need to change this if you run into actual problems. Autocomplete, basically, when you log out, actually I can just do it right now. You'll see that my browser has remembered the username and password. If you were to change that setting by unchecking this login autocomplete, it would simply place in the HTML of the page a request that the browser not store the username and password. Of course, it doesn't mean that it won't get stored. There are extensions and stuff for all the different browsers that defeat that. But if you're more security conscious and you don't want your users to be just saving passwords left and right in their browsers, you can disable that. There's anti-lockout and WebUI redirect rules that you can disable. So the idea behind this is when you get into firewall configuration, it's very possible that you can write a firewall rule that effectively makes it such that you can't access the web user interface anymore. And of course, that would sort of brick your router. So there are by default anti-lockout rules in the firewall that have the highest possible precedence. So the idea is that even if you add a firewall rule that would lock you out of the UI, the anti-lockout rule precedes it such that it won't happen, and you always have access to the UI. But you can disable those default rules if you wish, but generally speaking, you'd only need to do that if you were doing really crazy stuff and it was interfering with it. Generally speaking, I would not check those boxes because you have a good likelihood of never being able to access your router again, and then you're going to have to reset to factory defaults or something, so not good. I'm not going into all of these things, like, most of these are, you can read these and know what they do. One of the things I like to check is the browser tab text. So right now, you'll look at the name in the page title. It starts with your hostname.domain, and then it gives you the actual name of the page. In this case, System Advanced Admin Access. But of course, if you have a bunch of these tabs, all they're really going to say is pfSense.localDomain, and then you're not really going to be able to read it. So when you make this change, what it's going to do is it's going to flip those around. So that way it says now, System Advanced with, pfSense at the end. So now if I open up a whole bunch of different tabs, you can actually see, I guess it would help if I actually, made changes. But now you can see it's easier to read what's in each tab now. So generally, I like to enable that. You can enable SSH onto your router, which I highly recommend you do if it's not a security vulnerability for you. And the reason for this is, right now, if I needed to get into the console and actually do something in the console, I'd have to physically plug in a monitoring keyboard into the box, and I would then get access to this interface. But you can use this interface over the network from any computer over SSH if you enable SSH. So I like to do that. I also like to change the default port, because SSH is one of the most popular things to try to hack into, basically. I generally like to change the port to something else. So in this case, I'll just make it 2222. And that way, it's a little bit harder for people to find your box and start hammering it brute force with password attempts. And you also have serial console settings. So like I mentioned in the install video, you can enable a serial terminal as well. So if you have a serial port on your device, you can actually hook up a serial cable and get the console from that as well. But of course, is a virtual machine. It doesn't have it. And if you're not going to use it, don't enable it, because it's just going to kind of slow down the boot up to some extent. Maybe not with a baud rate as high as this, but yeah, there's no point in enabling this if you're not going to use it. You can also password protect that menu as well. Obviously, as you saw, it just pops up with this menu whenever you boot it up, and you can just hit 8, which gives you just a regular shell. In fact, I can do it right now. And you have full root access to the system, which means anyone that can walk up to the router can plug in a monitor and keyboard and have full root access to the system, which of course is not really a good thing. And they can really mess up your network here. So if it's in such a place where they can actually get access to it, you may want to password protect that console menu. But of course, if you forget your password, you're fucked. So just be aware of that. So I'm just going to save this because I've enabled secure shell. And changes have been applied successfully. Wonderful. So I'm going to move to the next tab, and you'll notice that I've got an alert here. And the alerts and the messages in 2.3 are quite nice. If I click this, it's going to give me some notices. And these notices were because I just enabled SSH. So it had to generate the encryption keys for SSH, which it does in the background. So it's just notified me that the SSH keys have been created. So I'm just going to mark those as red, and the notification disappears. So if anything goes wrong, if there's a serious system error, you'll get a notification about it, so that you'll be notified if you get to the UI at all. No matter what page you're on, you'll be able to see that bell. So firewall and network address translation options. So a lot of these are really advanced options. I mean, we are in the advanced tab, and so I'm not going to go over a large number of these things. Just going to point out a couple things that I generally like to change. The first one is the firewall optimization. Now, by default, this is how the state table is managed. So under normal, it's the default algorithm. It works fine. However, you can change this, and generally speaking, I like to set it to conservative. And what this basically does is it waits longer before it considers a state to be stale, and it drops it. So this can actually improve things like VoIP and other weird UDP protocols and stuff that may have weird latencies and stuff. You can actually slightly improve performance on certain things by setting this. And it generally, they mentioned that it does use more memory and more CPU, but generally speaking, the amount that it uses over the normal algorithm is so microscopic that your hardware is probably OP already, so it doesn't matter. Unless you're running, a big business or something, and you have, hundreds of thousands of connections, in which case, then yes, conservative would start to have an effect. But for a small network like a home or a small business, conservative is probably actually a much better state table. High latency is used for really, really, really slow links. So if you were, for example, in the middle of nowhere and you had a pfSense router that was connected to a satellite internet connection or something, that would be when you'd use high latency. And aggressive is basically the opposite of conservative. It just drops stuff much more quickly. So if your router is underpowered, you may want to do aggressive, but generally speaking, most people are not in that situation. You can set up things like maximum states and stuff like that, but by default, it'll basically just use all the available memory you have left for states, which is generally fine. You'll never really reach that, so there's no point in really setting these limits unless you have real reasons to do that. The other thing that you'll see in a couple places is something referencing bogon networks. And basically what this is there is basically a list of IP addresses on the internet that are not assigned. Basically, they are addresses that are not being used right now. And you can receive traffic from these IP addresses. And of course, it's invalid traffic. It's generally hackers or spammers or something like that. Because, of course, you can't actually send the data back to them because the IP doesn't exist. They're just trying to get into your network or do something. So there's a list of these IP addresses, and your pfSense box can, on a schedule that you can set up. Generally speaking, this list doesn't change that often, so I leave it at monthly. It downloads this list, and if anyone tries to make a connection to your system from an unregistered IP address, it'll just be blocked by the firewall, basically. You can, of course, disable this feature in the firewalls, in the firewall configuration, but I just generally just leave it because, of course, I mean, it's there for a reason. And again, a lot more serious settings that most people don't ever need to think about. And moving on to the networking tab, we have some options about network interfaces and IPv6. So you can basically disable IPv6 if you do not want it on your router. So basically, by unchecking this box, it will block IPv6 traffic. It doesn't disable rules in your firewall for IPv6 traffic; it just blocks it completely. So if you have a network that doesn't have any IPv6 devices, disabling this is not necessarily a bad thing. It just prevents your router from dealing with IPv6, which can be nice. So I'll just disable IPv6 on my router because I'm not going to be talking about IPv6 like I've mentioned. I'm not going into that. You're kind of on your own for IPv6. Now the network interfaces section is actually quite important because this has to do with the drivers for your network cards. Now, I mentioned in the hardware video that for Ethernet cards, generally you want to go with an Intel card. One of the things that I neglected to mention, which was pointed out to me in the comments, and I appreciate that, was to do with 10 gigabit Ethernet cards. If you are running 10 gigabit Ethernet, generally speaking, Chelseo is actually more preferred than Intel because Intel screwed up their drivers on the first go around. For their 10 gigabit Ethernet cards. So Chelseo is actually a little bit better on the 10 gig Ethernet front, but of course, just regular gigabit Ethernet, Intel is still better on that front. So I just want to make sure I point that out. But regardless of what network card manufacturer you ended up going with, this section is still relevant. And the reason why is because this allows you to sort of augment how the system interfaces with your network card. So by default, your network card uses interrupts to interface with the system. So anyone who's familiar with digital computing architectures would understand what an interrupt is. But basically, the network card, let's say it receives some packets on the network. It puts them in a buffer on the network card, and then there's a special dedicated way it can basically tell the CPU, hey, I want you to deal with me. And the CPU will stop what it's doing, sort of basically drop everything. Then it will start running the driver's, what's known as interrupt service routine. It's basically a bit of code in the driver, which then handles that interrupt by going to the network card, pulling the data off the buffers, putting it into RAM, and then the operating system does whatever it does with it. And then the CPU goes back to doing whatever it was doing before the interrupt occurred. And this is the way that most cards work. And it's the preferred method, of course. It's much easier on the system to do it this way. However, the other way of doing I/O is to use what's basically called polling, where the CPU basically continually checks the network card on a schedule. So, every X, microseconds, the CPU checks, oh, does the network card have data? No. Does the network card have data? No. Does the network card have data? Yes. Okay, let's do something. And this, of course, causes a lot of overhead because you're constantly asking for data, whether it's there or not, you don't know. Now, generally, the only real reason why you would want to use polling is if you have a system that's under extremely heavy load and it crashes because there's so many interrupts, the CPU can't get anything done and the system crashes or becomes unavailable. And polling, because it's on a schedule, you can guarantee that the CPU will have time to do stuff. It's really only something you should worry about if you actually have serious problems. And I'd recommend that you look online to see if the problems you're experiencing is really due to interrupt flooding. But that's what this option is for. The other options are slightly more important, though. The first one is hardware checksum offloading. So when you get a packet in on a network card, that packet is going to have a checksum in it. And a checksum is basically a mathematical equation that is computed on the data, and it generates a result of that equation, and that result is then tacked on the end of the data. So the idea is that the sender generates a checksum, sends the data and the checksum to the receiver. The receiver can then run the same algorithm, and if it gets the same answer for the checksum, then it knows that the data is correct. And if it gets a different answer, then the data is corrupted. Now, checksums are actually not very good ways of doing error checking, but they're very, very cheap and easy, and that's why they're used in this context. But good network cards have hardware in them to actually do the checksum computation. So the software basically just says, send this data, and the network card will actually do the checksum computation in hardware as it sends it out. The CPU, the software doesn't even have to deal with it. And the same thing on the receiving side. The hardware does the actual checking that the checksum is correct. The software doesn't have to even bother with it. The problem is, of course, some network cards suck at this. In particular, Realtek cards, it's just fundamentally broken on a lot of Realtek cards. So if you have a good Intel card, hardware checksum is going to work probably perfectly fine. So you're going to want to leave this enabled, so unchecked basically. But if you are using a card from Realtek or Marvell or something like that, you may want to disable hardware checksum offloading, just because it may be broken and may not work properly. It may cause problems. And the exact same thing with segmentation offloading for TCP, which is a higher level networking protocol, and large receive, again, more higher level stuff. These, in this case, by default, they are disabled. But if you have a good Intel network card, you can probably uncheck these, and it will probably work okay. Basically, my motto for this is basically enable offloading of everything. Like if you have a proper Intel card, enable offloading of everything. You have to reboot the system in order for these changes to be applied. So uncheck them all, reboot them, reboot the system, and then if everything still works fine, then you're all good to go. But only if it breaks should you then go back and fix it, and selectively determine which thing is broken, and go from there. But you only need to do that once, of course, when you initially set up the system. But you can get better performance if you use the hardware capabilities you actually have. So moving on to the miscellaneous tab here, I'm going to skip past load balancing and other things like that. I'm going to talk about that probably in a later video. One of the things you definitely want to look at here is the power savings section. And I'm really surprised this is actually disabled by default. Basically BSD has what's called the power daemon or power D. And what this does is this is a service which can control the CPU frequency, basically. All modern processors since like pre-2000, literally the last 16 years, have had support for basically dynamic frequency scaling. So the CPU can effectively change its clock speed based on system load. So Intel calls this speed step technology. AMD calls it cool and quiet. And it's pretty much, you have to enable it in the BIOS, first of all. Why it's disabled in the BIOS in some machines, I'm not quite sure. But check your BIOS for speed step or cool and quiet. It'll be under CPU options. Make sure that shit's enabled, because there's literally no reason to disable it, honestly. And once you've enabled it in the BIOS, then you can enable PowerD in the user interface. And basically what it gives you the ability to do is change how the CPU speed governor works. So with PowerD disabled, or with speed step or cool and quiet disabled in the BIOS, the CPU will run at maximum clock speed all the time. So it's going to be using a lot of power that it doesn't need to be using, and it's going to be producing a lot of heat that it doesn't need to be producing, which of course both suck. And then the other thing is the fans are going to have to run at higher speeds to keep it cool, which is going to make it louder, and the fans are potentially not going to last as long. So there's a lot of reasons why you want to enable this. And with your router's probably not going to be using that much CPU, as I mentioned. So enabling this allows it to downclock and save a lot of power and heat output. So you have the option to change the governor for 3 different states. So basically running when it's plugged in to the wall, running on battery, or basically when the system doesn't know what power state it's in. If you're running this on a laptop or something that has a battery, you can change that. If you have a UPS and the system actually knows about the UPS, like it's plugged in and the system actually can talk to it and get the battery status from the UPS, it will also work here. But generally speaking, I generally just set them all to be the same, and that way the performance, it doesn't matter what state the system's in, it's always the same. So basically there are 4 different types of governors. Maximum is sort of the easiest to understand. It's max speed all the time, so it's effectively the same as disabling power D, basically. Minimum is the minimum speed all the time, so it doesn't matter what the CPU load is, it will always run at the slowest possible speed. Adaptive means that the CPU frequency will change dynamically with load. So if the CPU is not busy, then it will run at a low speed, and as soon as work comes in for the CPU to do, the CPU will ramp up in speed, potentially not all the way. It'll ramp up to some intermediate frequency that's just enough to get the work done in a reasonable amount of time. And high adaptive is adaptive in the same way that it sits at a low frequency. When work comes in, it jumps up in frequency, but when the work goes away, the CPU drops back into an idle state where it's not really doing that much. Under the adaptive scheduler, the CPU clock will ramp right back down very quickly, whereas under the high adaptive, it will actually it'll stay at the high clock speed for a while before it drops back down, sort of in the idea that potentially there's going to be more work coming in soon, and you don't want to have the performance loss of ramping back up to a high clock speed, because that takes a short period of time for the clock speed to change. This same governor is used. These governors are used in Linux. You can actually set these in any sort of Unix-based system. They all have the exact same schedulers. Generally speaking, I generally like to use adaptive because it's the most of a balance. You get the power savings, and you also get the performance when you need it. Generally speaking, the only time when it's going to up clock is when you have a large amount of traffic going through it, or if you're interfacing with the web user interface and it's generating web pages or graphs and stuff like that. That's when it's actually going to need to use the CPU for something pretty serious, and that's when not keeping it at minimum is actually a good thing. Now, there's no point in me enabling this in my VM, because VMs do not have the ability to control the CPU governor. So if you're running in a VM, the actual host operating system is what controls the CPU speed, not the VMs. So if you have a hypervisor or something like that, that's what you want to change the governors on, not your VM. So I'm not even going to enable this because it's not going to do anything on my system because it's running in a VM. The next thing is cryptographic hardware. So basically, if you're running OpenVPN or something, and of course, if you're running, in fact, any VPN, your traffic is going to be encrypted, and there's going to be a lot of traffic passing through the router, and every packet is going to have to be encrypted, and that encryption can take a lot of CPU time, and that can slow down your VPN. So if you have a modern CPU, it may actually have support for different types of encryption in the actual CPU. Basically, there are special instructions in the CPU which are designed to aid with doing certain types of encryption. And it allows the CPU to encrypt things very quickly if you use those particular types of encryption ciphers. And if you have an AMD system, you may have the AMD Geode cryptographic engine. If you have an Intel CPU, you may have the AES-NI accelerator. So check, just go to, just basically Google what CPU you have in your system as to whether it has built-in cryptographic acceleration. It's easy to find AES-NI data. I'm not quite sure about the AMD stuff because I don't use AMD CPUs very often. But just check to see if it has it, and if it does, you can always just enable this, and that will severely improve cryptographic performance if you use if you use the algorithm that the CPU actually supports natively. Of course, if you use a different cipher that the CPU doesn't have acceleration for, it doesn't matter whether you've enabled this or not. It's not going to use it. But just check and enable this if you have it. In this case, I know for a fact that I do have AES-NI on this system, so I'm just going to enable that. The next part is thermal sensors. So, of course, you may want to be able to monitor CPU temperature, motherboard temperature, all that kind of stuff. If you don't have thermal sensors in the system, like if it's a really ancient computer, just leave it at none. But if you have any modern Intel system from the last, decade, enable the Intel sensor. Of course, if you have an AMD system, enable the AMD sensor. And of course, you have to reboot for both of these options to take place. But when you do that, it will actually show you the actual core temperatures of the CPU, and it will log those if you want. So again, I'm in a VM, and the VM doesn't have access to the thermal sensors, so this won't actually do anything. But if you're running on physical hardware, when you reboot, you should see the thermal sensor information. There's a widget on the dashboard you can add, and I'll show you that in a moment. That will show you this information in real time. Going down a bit, there's a bit to skip over. RAM disk settings. This has to do with basically people who want to run pfSense on a flash drive. So if you're running on a hard drive or an SSD, you don't need to really bother with this. But if you're running on a USB flash drive, an SD card, a compact flash card, you're running off some sort of low write count solid state media. The problem with those, of course, as I mentioned in the hardware video, is that they don't really tolerate writes very well. As you write data to them, they'll wear out very quickly. So, of course, the logging and stuff that pfSense is going to do is going to continually make a bunch of little writes, and eventually it's going to kill the drive. So what you can do is you can actually basically create virtual hard drives in RAM, in the system memory, and that way all those little writes don't get written to the actual disk. And the idea is that you can basically back up those at a lower frequency. So you can create RAM disks of certain sizes, and then you can basically, they'll get written every couple seconds or whatever, and then every couple hours, whatever hour you specify, it will basically dump the data in those, RAM disks to the actual, flash media. So that way, of course, if you power off the system or there's a power failure or something, you don't lose all the data, because, of course, if it's in a RAM disk, RAM is volatile memory, it loses power, it loses all the contents. So these memory file systems are really only useful if you have, if you're running this off of a flash drive, which I'm not, so I'm not going to touch this. The other thing is hard disk standby time. If you're using a solid state drive or a flash drive or SD card or something, don't touch this. If you're using a mechanical spinning disk, you can basically change how long before the disk will spin itself down. In most cases, you probably don't want to set this. You probably want to leave this always on. My experience with doing this, not just on pfSense, but on any machine, is that it'll either never spin down anyway, or it'll spin down and then immediately spin back up because something needs to be written to it. So all you'll end up doing is burning out the drive by spinning it up and down, up and down, up and down all the time. So I just leave it on. Disks are generally designed to, continually spin. So I don't really see any reason as to why you should change that unless you know your hardware and you know that it's not going to be always cycling on and off. One thing that would actually I guess I'll just mention this. One thing that maybe would make sense is if you had a mechanical disk and you were using RAM disks for all the temporary stuff. In that case, because the RAM disks are getting written to all the time, you could probably, let's say you only backed up once every 24 hours, then maybe you could actually spin down the disks, and maybe in that case it would work. But other than that, I can't think of a big reason why you'd want to do that. Moving on to system tunables. These are kernel tuning parameters, and I'm not really going to talk much about these because these are really for people who who know what they're doing. When I did the video on the installation, and I did that sort of second half where I showed you how to change some kernel tuning parameters if you had issues with memory buffers for your network card driver. What we were effectively doing was we were setting kernel tuning parameters on the system. And these, you'll notice they have the exact same sort of format. That's exactly what these are. These are kernel tuning parameters that you can edit in the web user interface directly. Of course, we could technically set those, the tuning parameters that I set in the install video, we could set them here, but of course the reason we had to set them in the console was because we couldn't get the web interface because the network cards wouldn't work. So you can edit things directly in a text file, in bootloader conf, or you can do it here. But generally speaking, if you don't want to break things, don't touch stuff in here, unless someone on a forum or something has told you to do so. And lastly, in the advanced section, there's the notifications tab. So pfSense has the ability to notify you if something goes wrong. And you can do this with Growl. So you can set up a Growl server and it will send notifications there. I don't have one, but I do set up email. So basically pfSense will just send me an email if something goes wrong. Of course, your internet connection has to be working in order for the email to actually get to you. But generally speaking, it will. Unless something horribly has gone wrong. It's pretty standard email configuration, so this is all going to depend on how you do email. The nice thing is it will not necessarily send from the actual router itself. So if you don't, if you're, let's say, on an IP address that can't send email, you can actually set it up such that it will send from another email account. So you could actually create, for example, a Gmail account for your router and then enter the Gmail login details here as the from, and it will actually basically it'll connect to Gmail, send the message from that account, and then it can go wherever. So if you're on a residential IP address like I am, I can't send email from my IP address because it's in a blacklist for most email providers, but of course I can use Gmail to send things. So you can enable that all here if you want. And I generally would recommend you do that. You're not going to get spammed with emails. It will really only email you if something goes horribly wrong. So to the point where, if it sends, if there's, a little alert that it brings up, generally speaking, it would email you that alert so that only really severe things will get emailed to you. It's not a spam type notification system. And lastly, at the bottom, like I mentioned in the install video, there's a startup and shutdown jingle that it plays, and you'll only hear that if you have a PC speaker connected to your motherboard. But if it's annoying, you can disable that. I think it's awesome, so I'm going to leave it enabled. Again, if you're in a virtual machine, you're never going to hear that sound because virtual machines don't have PC speakers. So now that we've gone through sort of the system configuration, I'm now going to start working my way through all the tabs that I'm sort of going to gloss over a little bit, just to show you where things are, not really talk that much about them. So there's a certificate manager, and this will allow you to set up your certificates for things like OpenVPN, your certificate authorities and stuff for that, as well as for self-signed HTTPS certificates and stuff like that. You can add that here. So there's always a default certificate that's a self-signed WebUI. They call it the web configurator certificate, and that is if you take this certificate and you put it on your local machine, you can use HTTPS without a problem. But you can create your own certificates for VPN and all that kind of stuff. And when I go over OpenVPN, I think that's probably when I will touch on that. High availability sync. So pfSense has the ability for failover. So the idea is you can have multiple pfSense machines connected together, basically, and they synchronize themselves in real time over a dedicated network link. So you would actually have a network card on both machines that's dedicated for this sync, and they'd be connected directly, basically directly together through just a single cable. And the idea is that if one of them blows up or crashes or something horrible happens to it, the other machine has exactly the same information on it, the exact same config. It even has the exact same states in the state table. It actually syncs the states. So basically, it would fail over very cleanly. The people behind the firewall would not notice that anything happened. All their connections would stay working. It's really quite awesome. And you can set that up if you really need a high availability system, like I said, if you're in a company or a business or something where downtime is just not acceptable. But of course, for most people in the home, it's not really practical to run two router boxes because it's overkill. I mean, if you want to, you can do it. I may try this out in a virtual machine. I'll make 2 VMs and I'll set them up in a high availability setup just to show you how it works. But I'll do that later on if anybody wants me to do it. It's not really that critical because I don't think there are going to be that many people doing it. But at the end of the video series, I'll probably deal with that. And this is all just information as to how to configure that. You can log out. You've got a package manager. This is how you install and manage packages. Basically, these are like add-ons, the plugins for pfSense. And you can view the current list of all available packages. And you'll notice that, there are things like, Snort and Squid and all sorts of stuff in here. And I will be going into some of the packages. I will not go into all of the packages. I don't see myself installing all of these and explaining all of these because there are some of these that I have no idea what they do or how they work. I'm not an expert in this, so I'll selectively do some of these at a later date. But again, I'm going to go over the core pre-installed functionality first, and then I'll go into packages later. But this is how you deal with updating packages and all that kind of stuff. Routing. This basically shows you your gateways. So if you have multiple WAN connections, you would see them here, and you can make changes. You can set up groups and do more advanced configuration for bigger networks that I don't think most people are going to be doing. You can simply rerun the initial setup wizard if you wish, but generally speaking, you can get to all that information on other pages. So there's kind of no point. The update page allows you to manually run an update. If there's an update, you'll see it on the dashboard. You can actually disable the dashboard audit check for updates, so you can actually make it so that you have to go into this page to see the updates. But I've already updated, and so there's nothing to do. And under the update settings, this is where you can actually disable the automatic check if you don't like that. And you can also basically set up how you want the software to update, whether you want it to basically choose only stable releases or development releases. It's by default it's set to stable if you installed a stable image, or development if you install a development image. So because I'm installing the beta of 2.3, it defaults to development. But if I, for example, installed 2.2.6, which is the current stable, this would default to stable. So you can change that here. And then there's a user manager, and this is where you can add and remove users. So you can have different accounts for logging into the web user interface. You can set up permissions for each of those users, so that way you can have certain users can only access parts of the UI if you don't want them screwing with other things. You can also set up different authentication setups. So you can use LDAP, for example, if you want to. If you have, let's say, a corporate network and you don't want to have to manually add accounts here, you can actually just authenticate with another authentication server, like dedicated authentication server on the network. I don't have that. Most people are not going to have that. Again, it's another business thing primarily. But you can set up users here for OpenVPN and things like that. So under the Interfaces tab, we can see the interface assignments. So these were the interface assignments that were done when I installed pfSense. I did this in the console, where I assigned EM1 to WAN and EM0 to the LAN. But you can do that here, and you can change these as you wish. If you have extra network cards that you maybe didn't configure right off the bat, so if you had other interfaces you didn't set up, they would appear here, and there would be an add button, and you'd be able to basically create a new optional interface and set its basically which network card it corresponds to. And you can see here I can actually delete the LAN because that is still technically allowed. So you can delete optional interfaces and manage them here. You can set up groups and other more advanced configurations. If you have wireless interfaces, like actual wireless cards in the machine, you can manage them from here. However, I don't recommend you do that, but they will appear here if they are compatible to some extent. VLANs are configurable here, so you can add VLANs. Basically, you select the interface, you select the VLAN tag, which is that integer that I talked about, and this is how you can create VLANs. Queue and queues. This is I'm not entirely sure what this is. This is a new thing to me. This is, from what I understand, this is basically a more advanced version of VLANs. But I don't really know what necessarily all of these things are, to be honest. These are for much more advanced setups than anything I've ever created. You can also set up bridges, and you can set up link aggregation if you have a setup where that actually comes directly from your router. So that covers the Assign tab. All of the interfaces that you have actually set up or assigned, basically, will appear in this list, and this is where you can actually do the setup for those interfaces. So of course you can enable and disable the interface at will. You can change its name. They call it the description, but it is in fact the name of the interface. So by default, LAN and WAN are provided for you, but if you add any more interfaces after LAN and WAN, they're just going to be called opt1, opt2, opt3 for optional interface number, whatever, which of course is kind of boring. It's not very descriptive. So generally speaking, I would change their names. So for example, if you have a wireless LAN interface, I would call it WLAN, or maybe a guest wireless interface for GWLAN. That's a convention I follow. It's a convention I think most people follow, but you can call them really whatever you want, and that's what they're referred to in the user interface. Now you can change the actual settings for each interface, and this will of course depend on what interface it is and what it's connected to, because of course they're going to be different. I'll do the WAN first because I think this is the easiest and it's generally similar for most people. This was stuff that was configured during the install wizard, but your WAN is probably going to be DHCP. So your modem is going to have a DHCP server on it, and what we want the WAN interface to listen and basically use the DHCP protocol to automatically configure the interface for you. Again, if you have a different type of modem, then you would of course set that up as you wish. Static is generally not used on the modem side. It's going to be used on the other side. It's going to be used on your LAN side. And you can set up IPv6 on the WAN side. You can disable that if you wish, if you don't have IPv6 capabilities on the WAN side. You can spoof a MAC address. So again, if your ISP has told you need to do this, you can enter that in there or leave it blank to just use whatever the actual hardware MAC address is, because there's no point in spoofing something if the default works fine. Now, MTU and MSS, I glossed over this in the installer video, so I might as well explain what these really are at this point. MTU stands for Maximum Transmission Unit. So basically, this is the maximum size that a frame can be. So on a network, each network card can receive, in hardware, it's designed to be able to receive up to a certain sized frame. Generally, it's things like buffer size that affect it, and drivers to some extent affect it. And MTU basically works as a sort of minimal, basically the smallest MTU wins, kind of. That's why it's called maximum transmission unit. So if I have two nodes on a network and they're communicating, and the MTU is, let's say, 1500 bytes, which is generally the default for almost every network card. 1500 bytes is the default. So if they're both the default, then they're both going to be exchanging frames that are up to 1500 bytes in size. And so basically the packets can be less than that, but they can't be greater than that. So they need to be sort of split up if the data exceeds 1500 bytes. But if you have one that's using a jumbo frame that's, let's say, 9,000 bytes MTU, and one of them is still 1500 MTU, then the maximum they're going to communicate over is 1500 MTU, because of course it's the lowest common denominator between the two. But if all of the nodes that are communicating with each other have the same MTU, let's say they're both 9,000, they both have jumbo frames enabled, then that means that they can send 9 kilobyte frames. And the reason why you'd want to use jumbo frames is because jumbo frames are they basically have a larger payload to header size ratio. This goes down to how data is actually encapsulated in the physical level, but basically, as I sort of touched on in part 4 in the crash course, you have a payload, and then there are headers that are strapped to that, which basically give all of the routing hardware information as to what the packet is and how to get it to its destination. That header is a fixed size, and the payload is just the rest of the space until the whole thing is the size of the MTU. So if you increase the MTU, the header size doesn't change, but the payload does. It gets bigger. So the idea is if you're transmitting a fixed amount of data with larger packets, with larger frames, you would have less packets to transmit the same amount of data. And the less packets you have, the less headers you have to transmit, and therefore the less overhead. So the throughput is better. That's the short of it. Hopefully that made sense. So if you have in my case, I generally set everything on my LAN to use jumbo frames because all of my hardware supports it. However, your WAN probably will not support jumbo frames. I have yet to see a modem that accepts jumbo frames, mostly because your ISP's network is designed not to. It's designed to only work with 1500 byte MTU, and that's it. So because this is the WAN, I'm just going to leave it the default, which is 1500 bytes. You'd actually technically don't even need to enter that. It'll just sort of leave the default adapters. In fact, you know what? I'll just leave it blank. It'll default the adapter's default MTU, which is 1500 in most cases. It might be something slightly different, maybe like 1490 or something like that, but it's really close to that. MSS is something that you will need to probably set if you use jumbo frames anywhere else in your network. And the reason for this has to do with TCP, and this is layer 4 stuff that I didn't really talk about. I didn't talk about TCP or anything like that in part 4. Basically, TCP uses segments, and basically, to explain this in the simplest way possible, if you have jumbo frames on your LAN and a device on your LAN sends a jumbo frame to your router, and your router is supposed to send that out to the internet. The problem then becomes you've sent, let's say, a 9K frame in, it's got to send a 1.5K frame out, and it's going to fragment that in order to make it work. But if it contained TCP data, certain TCP data, it can actually basically not necessarily corrupt the data, but it can create a stream of data that the receiving end is not expecting. And encrypted HTTPS connections, for example, generally don't work if that happens. So, I actually had a setup where someone had actually configured pfSense, and they had set up jumbo frames on their LAN, but they hadn't done it. They hadn't set the MSS. And what ended up happening was if they went to an HTTPS website, which I mean is most websites these days, but back then it wasn't. It wasn't every website. They'd go to these websites and they just wouldn't load. They'd give like encryption errors and stuff like that. And it's because the data was getting fragmented and it broke the encryption basically. So basically, what you want to do is set the MSS, basically the maximum segment size clamping, to be the MTU of your WAN. So because the MTU of the WAN is 1500, then the maximum segment size for that should be 1500. So that way, any machine on your LAN which needs to send TCP data out to your WAN knows that it can only be maximum 1500 bytes, and it doesn't try to send jumbo frames out to the WAN, which would of course be bad. Hopefully that made sense. That was a little off the cuff, but yeah, basically MSS needs to be the MTU for the WAN in most cases. If you know what you're doing, ignore that, but that's generally how it would work. And of course, you wouldn't set MSS on your LAN, you only would set that on your WAN. Speed and duplex, leave this default. I can't stress enough that manually clicking on 1000 base T-full duplex is not going to make it faster. All it's going to do is break things. By default, Ethernet is really good at negotiating speed. If both parties, if this and the modem that you plug it into are both capable of gigabit full duplex, it's going to be gigabit full duplex. You don't have to manually specify that. If you manually specify that, the other side may get very confused and stop working properly. So just leave the speed and duplex default under pretty much all circumstances. There's no point in needing to change that. You can specify advanced DHCP configurations here if your modem requires it, but generally speaking, this stuff is not necessary to change. And as I mentioned previously, there's the bogon networks, which is basically the reserved addresses that are not assigned yet. So you can basically, by leaving this box checked, any connection that is basically any packet that comes in from one of those networks is blocked if it comes in on the WAN, which is generally what you want. The other thing is this block private networks. Basically, I mentioned in the crash course video that there were certain blocks of IP addresses that are reserved. And I mentioned that there were three primary blocks that were for private addresses, and that they were illegal. They could not be on the internet. And they were, of course, the 10/8, the 172.16/12, and the 192.168/16 blocks. They were not allowed on the internet. So, of course, if a packet comes in on the internet from one of those addresses, well, that's impossible. It's obviously fake. It can't be that way. So by checking this box, just like the block bogon networks, it will block incoming connections and packets from private addresses on the internet, which is supposed to be impossible. Now, the only reason you may want to uncheck this is if you are in a double NATed scenario. So let's say that you have a modem router and you are unable to turn off the router functionality. So there's a firewall and it does NAT and you can't turn that off. In that situation, your router is actually, your pfSense box is actually, its WAN address is actually going to be a private IP address. And in that situation, you probably want to actually uncheck this in order to make everything work properly, especially if there's other things connected to the modem router on the WAN side of your pfSense box. In this case, because I'm in a virtual machine, and this virtual pfSense box is actually, it is double NATed, because my real pfSense router, my actual hardware router, is what's actually connected to the internet, and this pfSense machine is actually just connected to that. So in this case, it actually does have a private. It actually does have a private IP address as its WAN address. So in that case, I'm going to uncheck that, and I'll just apply the changes. And it may take a bit to apply these because it's going to have to reload the WAN interface. Okay, and I'll just show you so that you can see. If you look at my WAN interface here, you'll notice that the WAN interface is 192.168. I mean, that is a private IP address, and it's because it's double NATed. So if that's a good way, I guess, to check to see if you are in a double NAT scenario, is to see what the IP address you've got on your WAN is. If it's an internet address, so it doesn't start with one of those 3 reserved blocks, then you know your modem is running like a proper modem. But if you see a private address there, it's because you're probably in a double NAT scenario, and that's, I mean, I feel bad for you if you're kind of forced to do that because you have a bad modem router. Anyway, moving on to the LAN. The LAN is pretty much the same thing, except on the LAN, generally speaking, you're not going to be connecting to a DHCP server. You're going to actually be the DHCP server. So in that case, you're going to need a static IPv4 address for that. Again, you can set the the MAC address and things like that. In this case, I'm actually going to set a jumbo frame MTU, and I'm not going to bother to set the MSS there. Again, I'm going to leave speed and duplex the same. Now, instead of the DHCP options, you're going to see the static options, and in this case is where you pick the IP address of the router on the LAN. So in this case, I'm just going to leave the default, but you can make this whatever private address you want. However, the convention in most networking is that you use basically the beginning of an IP block for the router. So you would use basically a .1 at the end for your router. I mean, there's nothing that's going to stop me from making it, some arbitrary number like that, but generally speaking, that's odd because it just looks like any client at that point. You want the router to actually be usually the first address. That way, it's just a convention. So most people will do that. And in this case, you don't want to block other networks, of course, because you don't know. This is the LAN. You're not really protecting yourself from anything because, of course, you're already on the other side of the firewall, so everything should be protected. Now, you'll notice that I got an error when I tried to save this page, and the reason for this is because I've got a DHCP server. The DHCP server for IPv6 is enabled by default, and of course, I need to disable that in order for this setting to work, because of course, I can't track interface, and I can't set this to none, because if I set this to none, of course, it's still trying to run an IPv6 DHCP server on this LAN interface. Of course, that would require this have an IPv6 address. So the easiest way to deal with this is I just need to go to the DHCP v6 server and disable that on the LAN. And if I save this, so by disabling the DHCP v6 server, I should now be able to save this page, and there we go. So I'll just apply the changes, and we should be good. Okay, so that sort of covers the interface configuration pages. Moving on to the firewall. Firewall configuration is going to be a whole video, several videos probably in itself. You can set up aliases in the firewall, so basically rather than referring to IP addresses directly, you can set up basically you can give a name to an IP address or a domain name or whatever it might be, and that way you can also do that for ports as well as other things, not just IP addresses. I should mention that. And the idea is that if you use that same host or IP address or port or whatever in a whole bunch of rules, if you want to change that, rather than going through every single rule and updating each one individually, you just have to update the alias and then it changes everywhere automatically. So you can set that. It's kind of like a domain name for firewall rules, kind of. Anyway, so port forwarding, which is probably something that you're all familiar with your regular, wireless routers. It's exactly the same thing. However, of course, it's a lot more feature filled. You can make a lot more changes and a lot more configuration options than you've probably ever seen before. And I will go over all of this and a bunch more other things to do with port forwarding and NAT. This is the rules. These are basically all NAT rules are firewall rules, but not all firewall rules are NAT rules. So this is basically a list of all of the rules that the firewall has, and they're categorized by your interface. So you have rules for your WAN, rules for your LAN, and then floating rules, which don't necessarily apply to any interface. They may apply to all interfaces. So, for example, on the LAN, you'll notice that we have an anti-lockout rule. So this is what I was talking about in the general configuration. So we have basically this rule, because it's first, it makes it such that you cannot lock yourself out of port 80, or in this case, so that's the web interface port, and port 2222, which is what I made the SSH port. So that's the anti-lockout rule, and you can actually see it actually keeps track of how many times it's evaluated the rule, how many packets and bytes have been associated with that rule. That's a nice new thing that they added in 2.3, which is kind of nice. And there are some default rules that are provided for you, and one's in this case is for IPv4, one's for IPv6. The IPv4 one is basically the allow LAN to any rule. So the idea behind that is you should allow, you probably want your LAN traffic to go to the WAN. So what this does is it says, all traffic on the LAN should, make it to the WAN, and you can set up such that certain traffic can go to certain interfaces and not. So this is how you would do. You could have another, when you add another interface for, let's say, a guest wireless network, that would appear here, and you could set up rules such that the guest network is allowed to access the internet but not allowed to access the LAN. So you could sort of firewall off and separate things. So when I go over the firewall, that will all be made clear, and I'll go over how to do that. Floating rules is how you set up when you want to do traffic shaping and things like that. You can set up floating rules that basically match certain types of traffic and then you can associate them with queues and limiters and other things like that. The other thing is schedules, and the idea behind this is that you can basically set up they're just called schedules, and you can set them up with a time and date and all that stuff like that. And you can associate all firewall rules with a schedule such that they only take effect during the schedule. So for example, if you want different firewall rules to take effect at different times of the day, maybe at night when the network is busy, you want to have different rules, you want to block the kids from doing something, or whatever, you can have it automatically change rules at different times of the day. So that's what the schedule is. There is a traffic shaper in the firewall, of course. This is installed by default, and you can see all the traffic shaper configuration by basically both by queues or by interfaces. But of course, there's nothing populated by default. And generally, the way that most people start with the traffic shaper is you go through the wizard. And I will be doing a video on traffic shaping, of course. There's another type of traffic shaper called a limiter, which basically just limits the bandwidth. It just hard limits a bandwidth for a particular type of traffic. So it doesn't do any kinds of hierarchical fair service curve or anything like that. It's just a hard bandwidth limit. So you can simulate different types of traffic, different types of links and interfaces. So you could effectively say, that computer, I want to simulate a 56K dial-up modem because I really don't like that person or something like that. So yeah, limiters are another type of traffic shaper that I'll go over later on. And virtual IP addresses you can also configure here. So moving on to services, most of these things are going to have their own videos, if I do a video on them, that is. Captive portal is basically, I'm sure if you've ever gone to an airport or you've been on a train or something and you've connected to the Wi-Fi and it sort of hijacks your browser and redirects you to some web page where you've got to accept the terms of agreement or maybe type a password in or whatever. That's a captive portal, and you can set those up. So you could have a really professional looking guest network if you wanted it. So you can set that up with the captive portal. I'm not going to be talking about the DHCP relay in this video series. It's basically the idea that if you have a DHCP server on one interface, you can relay it through to another interface, like if you have an external DHCP server, but most people are not going to have that configuration, so I'm not going to be going over that. The DHCP server is definitely going to be one of the next videos coming up. And the DHCP server, of course, is what gives the configuration to all the clients on your network. So there's going to be a lot of talk about this. And of course, there are different servers for each interface, other than the WAN, of course, because the WAN was configured to not have a DHCP server on it. So all of your interfaces would appear as tabs, and they all have independent DHCP servers on them. Again, there's the same thing with DHCP v6, which of course I'm not going to be going into. There's two different DNS services here. There's what's called the DNS forwarder and the DNS resolver. And I'm going to talk more about these, of course, in the DNS video, which is going to probably be right after the DHCP video. But the reason why there's two of them is because originally there was what was called the DNS forwarder, and this is DNS mask. The service is called DNS mask, and these two basically do the same thing. However, DNS mask is the old service, and the DNS resolver uses what's called Unbound, which is a newer service. And I get the feeling that in the future, the DNS forwarder, DNS mask, is going to get removed from pfSense. So I'm going to be talking about the DNS resolver. I'm actually using the DNS forwarder in my actual network in my house on 2.2.6 because that was the default way back when I set it up originally. So I'm going to be going over the resolver just because that's the default now, and I think probably in the future the forwarder may be deprecated. I'm not quite sure, but just in this transitional period, both of them exist. They both do the same thing, and that is that they basically they cache DNS servers on the internet locally on your router. So as clients make DNS queries, the router will cache those, and if the queries are made again within a certain period of time, they'll be served directly from the router over the LAN. And I'm going to do a whole video on DNS, and you're going to see with graphs how incredibly fast the DNS resolver is. That will be coming up. So then we have dynamic DNS. So if you have a dynamic domain, dynamic IP address that changes all the time, and you have a domain name, and you want that domain name to track that IP address, you can of course set up dynamic DNS. And pfSense has built-in support for a whole bunch of DNS, dynamic DNS providers. I particularly use Namecheap. I actually don't use the dynamic DNS client built into pfSense because I actually have a script that runs on one of my app servers that does it, and I've just never bothered to set up my pfSense to do that. So maybe I'll switch over one of these days. But I'll go over how to configure this, which is of course really nice because once you have a domain name, johndoe.com, whatever it might be, and they're generally not that expensive. I mean, they're $10 to $15 a year. Get it from like Namecheap or something. Namecheap has built-in dynamic DNS support, so you just configure it on this page, and then no matter where you are in the world, you can just type in johndoe.com, and it will redirect to your home regardless of what the IP address is, regardless of when it last changed. So you don't need to know what the IP address is. You know that, because your router knows what your IP address is. Every time your router detects that your WAN address has changed, it just basically sends a bit of data to your dynamic DNS provider, telling them to update your domain name's IP address to point to your new address. So I'll go over this in a later video. I'm not going to really talk about the IGMP proxy that much. Load balancing, the idea behind this is that you can have multiple servers on your network, and with pfSense you can basically aggregate them together and make them appear as one sort of virtual machine from the as the outside world would see it. So if you're running, let's say, multiple web servers, you can distribute the load across all those servers and have the pfSense router actually manage that for you. I don't know if I'll get into this, probably near the end of the video series, just because this is something that probably not many people in their home are actually going to be using. I'm going to do a video on NTP in the next subpart, so I'm not going to talk about that right now. PPPoE, I'm not going to go into this probably at all in this video series either. SNMP, I'm also not going to really go into this in this video series either. UPnP, I will go over this. This is basically it's basically a service that allows clients on your network to open ports on the firewall at will. So the idea is, let's say that you're running a computer on your network that runs BitTorrent. Of course, BitTorrent needs port forwarding to work. Now, you could do this one of two ways. You could either go to your firewall, set up a NAT port forward for that machine, or you could enable UPnP such that that BitTorrent program can just talk to your router and say, hey, I need you to open some ports for me because I need to do this. And then the router will open those ports, and then when the BitTorrent client stops, the router will, close them back up again. So you can dynamically open and close ports on the firewall, kind of like DHCP, but for the firewall. So you can do that here, and you can also set up limits and other sort of traffic shapey type things to do with these, which of course is useful, of course, because most of the stuff is used by peer-to-peer things like BitTorrent, for example. So I'll go into that at some point. And Wake on LAN. Wake on LAN, or WAL as it's sometimes known, is an interesting protocol over Ethernet, and the idea is when your computer's off, the network card is actually still on. If you have a desktop computer, the network card probably never turns off. And network cards have the ability to actually turn a computer on. So what you can do is you can send basically the network card when the computer's off. The network card sits there, and it's in a low power mode, but it's still on to some extent, and it's always listening for what's called a magic packet. And when a magic packet comes in, it will basically wake up the system and trigger it to turn on. So you can actually set up devices in this web user interface, and you can actually basically come in here and basically click on them, and you can wake a device remotely on your network, which is kind of useful. And you don't have to just do it from your router. You can do it on any device. It's just it has support built in for that. So moving on to VPN, I'm not going to be going over IPsec or L2TP. I'm going to be doing OpenVPN. So there's going to be a video on OpenVPN, of course, later on. Now that we've passed the services, we're onto the last two tabs pretty much, and this is for status and diagnostics. So this is where most of the tools are. Status gives you information as to what's going on with the services. Diagnostics gives you more system level information. So captive portal status, of course, would show you your status of the captive portal if it was running. CARP is the failover setup. Again, if that was running, it would be shown here. Dashboard, of course, which is the default landing page. That's how you can get to it from the status menu, or you can just click the pfSense logo. It takes you here as well. You can see DHCP leases on the actual machine itself, and this is one of the most common pages that I see myself accessing, and this lists all of the machines that currently have leases on the router. So in this case, you can see the computer that I'm currently on, this Windows 7 virtual machine, has a host name of PowerPoint, and there's his MAC address, there's his IP address. You can see when the lease was given out, when the lease ended. It's currently online. It's an active lease, and I can actually I can add a wake on LAN mapping for this machine. So I could, if this was a real computer, of course it's a VM, but if it was a real computer, I could actually make it such that I can automatically turn it on, and I can also add static mappings. And I'll talk about what that is in the DHCP video. I don't want to get too in depth in just this sort of brief overview of what's where. And you can see here is another pfSense VM that I had just spun up for a bit, and it's currently offline, and its lease is going to expire. So when you have a big network, this is going to show tens, possibly hundreds of leases, and you can terminate leases, delete them. Things like that. So I find myself using that a lot, and I'll go more into detail when I do DHCP. There's DHCP v6 leases, of course. If you're running an IPv6 DHCP server, you can reload the firewall rules by or the filter rules by going to this page. But generally speaking, that will be done automatically for you, so you generally don't need to. Gateways, this goes over all of your WAN gateways. So you can see the name of the gateway if you have multiple ones. The IP address, in this case, the gateway this is the IP address of my actual real pfSense router that actually is connected to the internet. Not this box, but my actual one. You can see the round trip time to the gateway. You can see the percentage packet loss. Its current status, which basically changes between online packet loss and offline. This is really, really useful. You can actually, there's a widget for this that you can add to the dashboard, and this shows you this, and I like to have that on there because you can view real-time packet loss and delay. And all of this information is actually aggregated by a service called apinger, and the idea is your router continually just sends out pings to your basically the nearest node on your WAN. And it measures the time, and it measures how many of those pings actually make it back, and that's how it can calculate the time and the loss. And that data is also graphed and stuff, which I'll talk about in just a moment. So you can see interface statistics, so you can see data about all of your interfaces if you wish. Again, IPsec stuff, which I'm not going to go into. Load balancer stuff, which I'm not going to go into. I'm going to talk about NTP in a separate subsection of this video, or in the next video, the next subpart. OpenVPN status, of course, that's not configured. Package logs, if you installed packages that have their own logging capabilities, you can see their logs here, and that's separate to the system logs. Queues, again, if you have traffic shaping enabled, you can see all of the traffic shaping queues here. RRD graphs, I'm going to do a whole video on this, which is coming up right after this one. So you can see the status of the running services, so you can see what's currently running. So you can see Unbound, which is the DNS resolver, is running. SSH is running. NTP is running. Dpinger, which is the I said apinger just previously. That has been replaced with dpinger. Sorry about that. So yes, that's another change that they've made between the 2.2 and 2.3 release. And of course the DHCP server is running. So you can stop services, restart services, or you can just go to their settings page quickly from this page. System logs shows the logs for all of the different services on the system. So this is the general log, and this right now I can't entirely figure out what is going on. Generally speaking, this is going to be filled with useful information, but I simply continue to get this same message repeated over and over and over again. This message, I've only ever gotten this on VMs, so I don't entirely know what this is. This might be VirtualBox that's screwing with the networking somehow, and unfortunately it's overwriting a bunch of useful log messages. But here is this log. You generally want to read this periodically to see if everything's going okay, because a lot of errors that would not be severe enough to bring up a notification are going to get logged here. So if something is acting weird, not working correctly, generally check the system log first, and that will give you generally insight as to what's going on. If there's nothing in here, then maybe it's misconfiguration. But if something has crashed or gone wrong, you'll see it in here, and you can see logs based on your gateways. So so this is dpinger. You can see DNS wireless logs, of course, if you had a wireless card in the system. Firewall logs, so you can see basically what's been blocked. DHCP logs, so you can see basically what the DHCP server is doing, what clients are making requests, and what in what order, and you can monitor all these logs for all the different services. Have logs if they're enabled, of course. And of course, you can change the number of entries in the log, so you can increase this. I generally like to use 200 because I like to see more. More is better, in my opinion. And you can tweak the way that it shows things. So in this case, now it's showing me 200 entries, and of course, it's just being spammed by this. But normally, you would see more useful things like that. And traffic graphs. These are basically real-time graphs for each of your interfaces. So you can select the interface you want to see a graph of, and you can basically it'll show you the real-time traffic. You can currently it defaults to bits per second and auto-scaling basically in auto-scaling up. So the idea is right now it just picks arbitrary 0 to 100 kilobits per second. But the idea is if traffic exceeds that 100 kilobits per second, it'll auto-scale up, but it won't scale down. And if you click this, it'll actually, you can change between following or up. So the idea is it'll either scale up and then back down again, or it'll just scale up and then it'll stay scaled up to the maximum speed that's ever been encountered on that interface. You can also use bytes per second if that's more intuitive to you, but generally networks are talked about in bits per second. And you can see in this list what devices are talking the most. And you can display either IP addresses or host names or descriptions or fully qualified domain names. So if IP addresses don't mean much to you, but host names do, you can put that here. So the idea is if I go to YouTube or something, you can see, there we go. You can see on the WAN. Actually, I guess that doesn't make much sense. Generally, you don't really want to see what's on the LAN because it's not very interesting. But if I go to the LAN, you can see that in this case, this machine, which doesn't have a host name set up because I haven't set up the DHCP server yet, you can see its bandwidth in real time here. And of course, you can see UPnP statistics here as well if you wish. Again, that has to be enabled first. So under diagnostics, you can see the ARP table. So I mentioned in part 4 what ARP was, the address resolution protocol. So this shows you basically what IP addresses are being assigned to what MAC addresses as far as the router is concerned. So like I said, every node has an ARP table on it, and the router is no exception to that. It has an ARP table, and you can actually just dump the table here. So you can see that IP address corresponds with this. Of course, the actual pfSense box itself, it's in its own ARP table. And of course, as your network has more devices on it, this would populate and fill up. Authentication stuff, you can sort of just test to see if your auth server is working. In this case, there's really no point in using it, but if I had LDAP set up, for example, you could test to see if your LDAP server is working properly by running basically a login test here. I'm going to do a whole video on backup and restore, so I won't talk about that here. Command prompt, this basically allows you to execute shell commands from the web user interface. So the idea is rather than going to your pfSense console, whether it be a physical console with a keyboard and mouse, or a keyboard and monitor, or an SSH shell, and you actually typing into this console, if I run a command here, it's basically the exact same as running the command here and clicking execute, and it'll just simply run it and give you the results back on the next page. It's a nice way of running quick things, but generally speaking, if you're going to do a lot of configuration or whatever in the console, generally better to use the console than to use this. But you can execute stuff. You can upload files to the system and do all sorts of stuff like this. This is and like I said, this is for advanced use only. Generally speaking, you won't ever need to use this stuff, but it's here if you want it. You can do a DNS lookup, so you can test to see how the DNS is working by putting in a host name and seeing how it returns data. So I can type youtube.com, and you can see that it's returned some results, some timings, all that information. I always keep going to the status tab because I commonly go to the status tab on my actual router. You can edit files. Again, this is an advanced thing. If you want to edit a configuration file, you can load a file. It'll appear here. You can edit it, and then you can save it back without actually having to interface with the file system or the console directly. These are just web interface tools that sort of try to make it easier to administer the system. You can reset the system to factory defaults if you want to. So basically, if you royally screw up, you can do this, or if you move the firewall to another place where the network's completely different, you want to just sort of start from scratch, you can do that without bothering to reinstall. But generally speaking, reinstalls are so quick and easy that I've never found myself to really be using that. Halt system is how you turn it off, so this is the power off effectively. And there's a reboot as well down here, which does the same thing, but that just reboots, of course. NDP table, this is IPv6 type stuff, so I'm not really going to go into that. Limiter information, if you have limiters, they're the traffic shapers, if you have those enabled, you can see the status of those. You can do packet capture, so the idea is you can actually intercept all traffic on a particular interface for a period of time or a certain number of packets, and you can dump that into a file, and then there are certain programs you can use to actually inspect the traffic. So if you need to do diagnostics that way, that is a possibility. pfInfo, this basically just gives you broad statistics on your system. So it gives you interface statistics, a whole bunch of trackers and things to do with the firewall, which most people don't really need to know about, but it can be interesting to look through this. You can of course look up what these things mean, and I'm not going to go into that in this video. pftop. This is basically a way of seeing which states have the sort of the most throughput, and so you can see sort of who's the top talker on the network, and you can just see sort of what states are open, how many packets and bytes they've transmitted since they were open, how long they've been open for, what protocol they're using. You can analyze your network with the default tools provided pretty well, and if you want more deep analysis, you can use NTOP and other things that do deep packet inspection, and then you start getting into the efficacy of doing things like that, of sort of snooping on people's traffic. You can ping hosts from the web user interface to see if they're reachable. You can look at the routing table. So this is basically the table that pfSense uses to actually determine when a packet arrives on an interface. It looks through the routing table to determine where it needs to go. So you can actually see what the kernel is actually using to do the routing. So if you think it's not doing something correctly, you can check here and see what's going on. You can look at smart status. This is something that is not going to work in my VM, but hard drives have smart statistics, self-monitoring, and reporting technology. So the idea is hard drives and SSDs they have sensors in them, and they have sensors, and they have data like logging capabilities, and they can track their health, and they can report those statistics to you. And of course, you can use that to determine whether the disk needs to be replaced. And the idea is that you would replace it before it prematurely fails. So you can get that information for your hard drive from here. And you'll notice that in this case it says that the smart command failed. And of course that's because it's a virtual hard disk. It doesn't have smart. But if you're running this on a physical machine, you could actually just click view, and it would dump all the drive statistics, and you can see how healthy the drive is. You can also perform self-tests and other things like that. There is a widget that you can add to your dashboard that actually just shows you sort of like a green or red all clear or warning. And I like to put that on my dashboard so that way I can, at a glance see if my drive is okay or not okay. You can dump socket information for the system, which is quite advanced. You probably don't need to deal with that. You can look at states in more detail. There's several ways of looking at states. There's also a state summary, and you can look at, you can inspect the state table with quite a fine-toothed comb if you wish. But generally speaking, I don't find myself doing that very often. You can look at system activity. This is effectively running the program called top. And what it's doing is it's showing you what's using up the CPU on the system and what's using memory and things like that. So you can see here the CPU is idling. The CPU has this particular system has 4 cores. So you can see here that, the system is pretty much 100% in idle. Right there, it's 100% idle. So it's not doing very much at the moment. But of course, there's really no traffic going through it. And you can see, PHP there, which is what's running the web user interface a little bit. So you can see that's doing a little bit of work. But this is where you would find out, where all your memory is going and where all the CPU load is coming from. You can look at different tables. So, for example, that Bogons table that I talked about, you can actually show the contents of that table if you want to find out if an address is in there or not. You can test ports basically to see if a particular port is open on a particular machine, and just it'll tell you basically if it's open or not. Which can be useful to find out if a service is configured correctly or a device exists and is up. And the other thing you can run is a trace route, so you can enter in a host name or an IP address, and it will basically, the way trace routes work is actually kind of cool, and maybe I'll go into that in a future video, but it'll basically send out a bunch of pings to all of the hosts, all of the routers between you and that host name. And it will basically print a trace of all of the nodes that the traffic passed through to get there. So that can be especially useful when you're diagnosing problems with your internet service provider. I've found that to be quite useful. Of course, a lot of these tools can be run from any console on any Unix system, but having a nice web interface for them is kind of nice. And then that just brings me back to the dashboard, of course, which you can add. Basically, you can add things by opening the Add Widgets button. And the couple things that I generally like to add, I like to add the smart status. Of course, in this case, it just says smart status is unknown because it's a virtual hard disk. It doesn't have smart. But that would normally be a green, good or bad, which I think is something that you probably want if you have a disk in your system. Traffic graphs basically takes the real-time traffic graph and puts it here, and you can configure it, and you can show which different graphs you want, how often it refreshes, all that kind of stuff. So I like to have those, and of course you have to click the save button for it to actually save your layout so that when you refresh the page, it's still there. Thermal sensors, again, if you have thermal sensors, it will show you a little graph of all the different zones, all the different cores here. So that would be nice to have. Of course, again, I'm in a VM, so I don't actually have sensor data, so that doesn't work. You can show your gateways. So this is that gateway widget that I mentioned. So it shows you your IP address of the gateway, the round trip time, and the loss and the status. So I always like to have this so I can clearly see, I have an internet connection. I don't have an internet connection. That you can just see at a glance there. Of course, if you have certain things like captive portal or load balancer installed and configured, you would, of course, probably want those widgets here. OpenVPN is also nice to have, so you can see how many users you have on OpenVPN, things like that. But and dynamic DNS and all that stuff. Interface statistics is another thing that I like to always have. This basically shows you the number of packets that have on each interface, the number of bytes that those packets correspond with, and the number of errors you've had. Interesting that I've had 17 errors on the WAN. It's probably because I brought down the WAN when I did the reconfiguration of the MSS and MTU. That's probably what that's from. But generally speaking, you shouldn't have very many errors here. If you're consistently getting errors, these are constantly creeping up in as your router runs, you may have an issue. It may not be fatal, but you may have a problem. I had a router with a failing motherboard that actually had errors slowly creeping up, and as that's what it turned out to be. It turned out to be an issue with the motherboard. So anyway, that's basically, again, you can get all that information from the diagnostics, but I like to just have it on my dashboard. The system information, which is always here by default, is really quite nice, and it gives you the system name, gives you the version it's on, and if you have enabled auto update checking, it'll print update information there. It'll give you information about the CPU. Of course, this is running on a VM, so this is on my workstation, so that's the CPU on my workstation. Now, if you have enabled PowerD, like I mentioned at the beginning, it'll actually show the actual current and maximum clock speeds right here in the CPU type area. But of course, because PowerD is not enabled because this is a VM, it doesn't show that information. The system uptime is located here. Current time, the DNS servers that are being used. So I'm going to talk about this when I do the DNS video. When the last config change was made, which can be useful to know. The state table size. So currently there are 15 states open. I don't think I've ever seen that number that low before, but then again, there's only one computer connected to it. And you can see I definitely have a lot of room. On a real network, this would definitely have a couple thousand states at least open, usually at a minimum. This is MBUF usage. So this is the number of memory buffers. So when I did the install video and I changed the number of memory buffer clusters in bootloader.conf.local, what I did was I actually increased the maximum number of this. So if you actually change those values, this maximum will change, and therefore the percentage will change. Depending on the system load, this may go up or down, depending on the amount of traffic. It may actually stay very stable. There are some systems that don't seem to allocate more memory buffers at all. You can see the load average. This is just a standard Unix load average, which sort of references number of processes waiting for CPU. Kind of. It's a very strange algorithm. It's just a number. If you don't know what a Unix load average is, you can ignore those numbers. CPU usage, which you can see is pretty much nothing, so as you'd expect. Memory usage, again, this is going to vary depending on how many services you have running, the size of your state table, all that kind of stuff. Swap usage, this is virtual memory, so on disk. If the physical memory usage doesn't get too high, swap may never actually be populated. It may always stay 0. But if you're running something like Squid or something that does caching, it may put stuff in swap just because that's the way it's designed, and there's nothing inherently wrong with that. And of course, there's disk usage, which in this case, I have a 16 gigabyte disk, and it's 3% full. So, yeah, I mean, pfSense really does not use that much disk. So anyway, that's it for part 5.1. So I'm going to do a couple other sub-parts on a couple of the things that I skipped over because I want to talk a little bit more in detail about those. So until those videos, thanks for watching.